Welcome back everyone to Learning by Teaching. We're in statics and we're gonna do problem 4.61, 0.62 and 0.63, okay? So it says determine magnitude of moment about my base AB. So I have this system with a base AB, also a moment of if we're doing it on the base BC and also CA. So I have this force over here, and what will be the moment that it will create around these bases, okay? So if we would like to do the moment about our base AB, what we'll need to find is that we'll need to find the unit vector AB. We will do the dot product between the unit vector AB and a distance between the base and the force, so for example vector AD, so in this case AD, cross product of my force. Okay, so if we want to do that, we will need to find the unit vector AB. So if we try to do the unit vector AB, we will need to do vector AB divided by the magnitude of this vector, okay? So what will be the vector AB? So in order to do vector AB, we do the position of B minus A. So in this case, what will be the position of B in the x direction, which is this amount, and it's equal to 1 plus 2.5, it's 3.5, minus 0, because A doesn't have anything in the x direction, so we got 3.5 in the I direction. Then in the y direction, B has 2 plus 0.5, and that will be equal to 2.5, minus the amount of A, which is only 2. So if I have 2.5 minus 2 will give me positive 0.5 in the J direction. Now in the Z direction, both of these guys are in the same plane, so we got 0, and actually they're at the 0 altitude, so we're fine with that. Now the magnitude will be equal to the square root of 3.5 squared plus 0.5 squared. And let's see what this is equal to. So we got square root of 3.5 squared plus 0.5 squared. It's equal to, so we will have 3.5 divided by my 3.54 in the I direction plus 0.5 divided by 3.54 in the J direction, okay? And if we do them into decimal, we'll find out that 3.5 divided by my 3.54, it's equal to 0.99 in the I direction plus, and then let's see how much is 0.5 divided by my 3.54, so it's equal to 0.14 in the J direction, okay? So we're good with the unit vector. Now we need to find the vector AD. So vector AD is going to be equal to the positions of D minus the positions of A. So in D, in the x direction, is 2.5 meters, and we already know that A doesn't have anything in the I direction, so we got 2.5. Then in the y directions, both of these guys rely on the same quantity, which is 2 meters, which are the same 2 meters for A. So basically we got plus 0, because we will do 2 minus 2 equals 0 in the J directions. And last, in the Z direction, we have that D is 4 meters minus 0 that A has. So we got positive 4 in the K direction, okay? So we found a unit vector, we found the vector distance. Now all we have to do is the moment about my base AB, and we'll find out that it is, so first the unit vector, which is 0.99 0.9 in the I direction, then 0.14 in the J direction, 0 in the Z direction. Then we do our AD, which is over here, and we do 2.5 in the I direction, 0 in the J direction, and we got positive 4 in the Z direction or the K direction. And last, we put our force, which is 50, negative 20, and negative 80. Okay? So if we do this, we'll find out that we need to hide this column and that row, multiply 0 by 80, negative 80, that will give me 0. And then we have 0 minus, and then the multiplication between negative 20 and 4, that gives me negative 80. So negative and negative becomes positive. And this is in the I direction. How much do we have in the I direction? We got 0.99. So we multiply this by 0.99. Then we do minus. And let's see, we'll hide this column, this row, the top row, and we'll multiply 2.5 by negative 80. So we got 2.5 multiplied by negative 80. That gives me negative 200 minus. And then we do 50 times 4. That will give me 200 as well. And then we multiply by the amount that we have for our axis, which is 0.14. Okay? So basically my moment about base AB is going to be equal to, so we have 80 multiplied by 0.99, so 80 multiplied by 0.99, it's equal to 79.2 minus, then we have negative 200 minus 200, that gives me negative 400, and we need to multiply by our 0.14, and that gives me negative number, so negative and negative, it will become plus 56.6. And our answer, so I'm gonna put it here in a little corner, so after I erase we still have the answer, is going to be equal to 79.2 plus 56.6. And it will be equal to 136. This is newtons per meters. Okay? So we're done with our moment about AB. Now we need to do the moment about my base BC. So we're gonna basically do the same, but we will need a different unit vector and different distance. So for the moment, okay guys, now we're gonna do back the moment about my base BC. So we need to find the unit vector BC, then we need to do the dot product between, and then we need to find a point between the base BC that goes to D. So for example, from C to D, so vector C D, cross product of my force F. Okay, so let's find the unit vector BC. So if I want to do my unit vector BC, we need BC divided by the magnitude. So if we need to do BC, we do C minus B. So C in the X direction has a total of 2 meters, and B has a total of 3.5. So we'll have negative 1.5 in the I direction. In the Y direction, Z has 0. So we do 0 minus how much the B has, which is 2.5. So negative 2.5 in the J direction. And then the magnitude is going to be the square root of 1.5 squared plus 2.5 squared. Okay? So if we do this with our calculator, we'll find out that first of all, let's do the square root. So square root of 1.5 squared plus 2.5 squared. That gives a total of 2.9. So if we do 1.5 divided by my 2.9, it's equal to negative 0.514 in the I direction. And then we're going to have negative 2.5 divided by my 2.9. So basically this guy was equal to 2.9. So we will have negative 0.857 in the J direction, okay? Now last we need to do is find CD in order to find our moment. And for CD we will do D minus C. So in the X direction, D has a total of 2.5 and C has a total of 2. So we'll have 0.5 in the I direction positive. Then in the Y direction we will have B, which is in the Y direction, it has 2 meters, and Z has 0, so we'll have plus 2 in the J direction, and then in the Z direction we will have a positive 4 because C has 0 and D has 4. So we got 4. Okay? So if knowing that, we know that we do that the moment about my base BC is going to be equal to, and then we do the unit vector, which is negative 0.54 in the I direction. Oh, I forgot a 1 in between. So negative 0.514. Then we have negative 0.857 in the J direction, and then we got 0. Okay? Now, we put our vector distance, which is 0.5, positive 2, and then positive 4. And then last, our force, which is going to be 50, negative 20, and negative 8. Okay, now this moment of BC is going to be equal to, so we do 2 multiplied by negative 80, that gives me negative 160, and then we do minus negative 20 multiplied by 4, that gives me negative 80. So if we do negative 80 over here, and then we multiply it by our unit vector, so negative 0.514, then we do minus, and then we are going to do, so if we hide this column and the first row, we have 0.5 multiplied by negative 80, so that gives me negative 40 minus 50 multiplied by 4, that gives me 200, and then this we multiply by our negative 0.857, and then we don't have to do the last one because this one is going to be multiplied by 0, so it's gone. So if we do these numbers, we will have, basically this parenthesis will do minus minus, will become a plus. So we will have negative 160 plus 80, all multiplied by negative 0.514. It gives a total of 41.12 minus, and then we do negative 240 multiplied by negative 0.857. It's equal to negative 205.7. Okay? And then finally, we will find out that this is going to be equal to negative 164.6 newtons per meter. Okay? So I'm going to write it out over here so we find our answer. So for BC, it's going to be equal to 164.6 newtons per meter. Since they want the magnitude, we don't need the negative sign. Okay? Now I'm gonna erase this. And we're gonna do our moment for the last problem, problem 63. Moment, form a base CA, okay? So we know that we need to find the unit vector CA, dot product of a distance in between CA, so for example AD, so AD cross product of my force, okay? So my unit vector CA is going to be equal to A minus C. So if I do A minus C in the x direction, I have A in the x direction has 0 and C has 2, so we'll have negative 2 in the I direction. In the y direction, A has a total of 2 meters, while my Z has a total of 0, so we do plus 2 in the j direction, and then in the z direction both have 0. And then now we need to divide this by square root of 2 squared plus 2 squared, and let's see what this is equal to. So if we do 2 squared plus 2 squared all in a square root, this guy over here only is equal to 2.83. So we will divide 2 divided by 2.83. So we got 2 divided by 2.83 gives me negative 0.707 in the I direction, and we will have the same quantity but positive in the j direction. 0.707, okay? In the j direction. Now we need to find the vector distance AD. So if we do vector distance AD, it's going to be in the x direction, so this amount, D has 2.5, so we got 2.5 in the I direction. Then in the y direction, both of them have the same, so I have nothing. And then plus 4 in the k direction, because D has 4 meters while A only has 0, so it's 4 minus 0. So we found that. Now we can find our moment about my base CA, okay? So if I do this, we put our unit vector, which is negative 0.707 for I, then we have positive 0.707 for J, we have 0 for C, and what do we have? Then we need to put our distance vector, which is 2.5, then we have 0 for the j direction, and then we have 4 for the k direction. And last, we put our force, which is described by the problem, which is 50 minus 20 and minus 80. Okay? Now, this moment, CA is going to be equal to, so we multiply 0, multiply by negative 80, that gives me 0, minus negative 20 multiplied by 4, that gives me negative 80. So minus and minus gives me positive 80. We multiply this by our negative 0.707. Then we do minus. Then we need to multiply 2.5 multiplied by our negative 80. So 2.5 multiplied by our negative 80, it's equal to negative 200. Then we do minus, we do 50 multiplied by 4, it's 200 positive. Okay, and we multiply this by our positive 0.707. Okay, so if we simplify these guys out, we got 80 multiplied by our 0.07, it's equal to negative 56.6. And then we have minus, and then we got negative 200 minus 200 is negative 400, multiplied by our 0.07 will give me minus 282.8. So basically minus and minus becomes a plus, so we got a plus in here. And my moment about my base CA is going to be equal to, so we got 282.8 minus 56.6 will be equal to 226 newtons per meter. Okay? So since these guys are magnitudes, we don't care about any signs, and we found our three answers. So we found magnitude for AB. So for the moment around my base AB, magnitude for the moment around my base BC, and the magnitude for my moment around CA. Thank you guys for watching. If you guys have any questions or any comments, please just put it down below, and I'll see you guys in the next video.